Welcome back. Today we are unpacking the cap theorem, a fundamental concept in distributed systems. So, first, what is a cap theorem? Cap theorem states that in distributed data stores and distributed systems, you cannot simultaneously provide consistency, availability, and partition tolerance. In other words, you can only pick two out of these three things. So you can pick consistency and availability, or consistency and partition tolerance, or partition tolerance and availability. Okay, let's break down each one of them. Start with the consistency. Consistency means that every node and every read receives the most recent write or an error. Example, like in a banking app, once you deposit money, every subsequent balance check should reflect the new total immediately. If a system is consistent, it behaves as if there is only one up-to-date copy of the data, even across multiple servers. So that means if we have multiple servers, all of them, or multiple nodes, all of them can read the same piece of data at the same time. Number two, availability. Availability, like it's a pretty easy to understand. Like every request, like read or write, receives a non-error response without the guarantee that it contains the most recent write. Like social media platforms often prioritize availability, ensuring users they can always post or view feeds, though some posts might appear slightly delayed. Like a highly available system never returns a system down error. There is always some valid response, even if it might not be the absolute newest data. Next is partition tolerance. Let me change the color. Next is a partition tolerance. Partition tolerance, the system continues to operate despite an arbitrary number of messages being dropped or delayed by the network. An example for that, like when servers are spread across different regions, network issues can cause nodes to be temporarily unreachable. Partition tolerance is essential in modern distributed systems. The network isn't perfect at all, so packets can be lost or delayed a partition, for example. So tolerant system will keep running despite these despite these problems. So in real world application or real world distributed systems, like we have three type of system. We have A, availability and consistency. So we have AC. We have availability and partition tolerance. So we have AB, and we have consistency and partition tolerance. So we have CB. And in a real world application, an AC system is not doable because we cannot ignore partition tolerance at all. So in practice, partition tolerance is usually non-negotiable for distributed systems. So the real trade-offs often is between consistency and availability. So it's between AB system or CB system. Let's talk about CB system now. CB systems, so like it's used for like when consistency is pretty important, like banking system or financial application, which prioritize correctness of data over availability. Maybe healthcare systems as well. They might halt operations in case of a partition to keep data consistent. We have AB system. AB system, like many social media or streaming services, accept slight data inconsistencies in favor of staying online. If a partition occurs, the system remains operational but might serve stale data temporarily. As we said before, AC system or CA system, it's rare in truly distributed environments, since partition tolerance is essential when scaling across multiple data centers. So it's between choosing AB and CB. And choosing CP or AB often depends on the business requirements. Like, do you absolutely need accurate data at all time, which is CP system, or can you tolerate eventual consistency so the app never goes down, which is an EB system? So, that's it for this video. In modern cloud and microservice architecture, partition tolerance is usually a must. So understanding the CAP theorem helps you to decide which trade-offs to make. Yeah, we have AB and CB system, and we did talk about them, and that's it for this video. And see you in the future.